Welcome, everyone. Welcome to this session, Effective Test-Driven Development. My name is Melvin Perez. I'll be sharing with you some ideas that I've seen can improve your test-driven development process. And I will get to what I mean by effective test-driven development shortly. But before that, we need to start talking about why this is important. So I'm going to start talking about certain things that we want to do in any software development project. We want to make sure that we remove defects as early as possible, because if we don't remove those defects early on, they start piling up, and eventually at some point they will be more expensive to find and more expensive to remove. So that's the whole point of building quality in. So if you see in this chart on the top, we're going to be creating defects somehow. We're going to be adding defects, making mistakes, misinterpretation of a requirement, or a typo that we introduce when typing the code. So if we are not finding those defects early on, they'll start piling up. If you start basically testing later, it would be more difficult for you to find it because you have a bigger portion of code, and obviously locating where the problem is will be more difficult. But then removing the defect will be also more risky, because now you need to make sure everything will work perfectly. Now, when we do try to find defects as early as possible, in other words, try to reduce that gap between when a defect is introduced, when that defect is found and removed, then we can have something like what we have on the bottom. So we have some savings in cost, savings in time. And that's what we would like to do in test-driven development. What tries to do is to put developer testing in practice. Developer testing is testing performed by the developers with the intent of finding those defects early on. So the benefit of test-driven development is that you can use this technique not just for finding defects, but also for preventing defects. So when you are writing the code, you're going to be preventing defects, because you're going to be asking questions, confirming your understanding, which is one of the main reasons for defects. Once you have the test, and now next time you need to touch that code, you can use those tests to find defects that you're introducing. Now you're touching the code. You would be able to use those tests as a safety net to identify when you're breaking the code. So as you can see in this quote, we find that designing test cases is one of the best way to prevent defects, because we need to start thinking about all the things that could possibly go wrong. Now, developers, we're not necessarily great in thinking about things that will be, breaking our code. We tend to think about possibly things like driving the code to be more on the happy path, if you like. Now, test-driven development, what we do is to say, well, do not write any code unless you have a failing test. So another way to think about this is that your tests are your requirements. So you have certain things you need to provide, some behavior you need to provide. And what you're doing is taking that behavior, breaking it down, and for each piece, you are taking that and expressing as a test. And when you execute this test, obviously it's going to fail. And then you write a minimal code that will pass that test. And then you take some time for refactoring. So a few things to keep in mind here is that even though we're using tests to guide this development process, test-driven development is not a testing technique. So we cannot say that because we're doing test-driven development, we don't need to do other kinds of tests. So when we do test-driven development, we're typically looking at developer tests that the developer feels they need to write based on the behavior they think they need to provide. And, the problem with this is that sometimes the developers will be so focused on this unit test that they will miss the big picture. They will have tests, they will have testable code. They will have a great number of automated tests that you can use. But at the end of the day, you may say, well, this is great, but it's not providing what we expect. So I would say that one of the things that we want to have in an effective test-driven development process is to make sure that we are providing the correct software. So as you can see here, the definition of effective is producing a decisive or desired result, something impressive. So we need to have a conversation about what do we want out of this process during the construction. And, speaking of test-driven development, here is important because we're going to be guiding the creation of the code based on those tests we're going to be writing. So in other words, the quality of your code may be affected by the quality of your test. And that's why we think we need to have this conversation looking at some techniques that typically any professional developer or any professional tester will know. And maybe we have heard of those testing techniques when we went to school, but now we're just focused on writing code and maybe on the refactoring, all the technical stuff, but not necessarily kind of training our brain to think about things that could possibly go wrong. So I have a few things here that I feel we need to try to provide in any software. It has to be correct. In other words, they have to implement what is expected. So we need to be driven by correctness, but also we need to make sure that the software is robust. That means that the software will react properly when it is, I would say, challenged. The inputs that we're expecting are being challenged. We provide different kinds of inputs. We put the software in a different environment that is unexpected, how the software will handle those unexpected scenarios. But also we need to make sure that the internal quality of the code is great. We want to make sure that we're creating clean code that is maintainable. But now we're talking about automating tests. We need to make sure also that our test code is also clean. And this is something I've seen on the field. I've seen developers using test-driven development process, but the way they are automating the test, they are not taking the same, I would say, being as careful as they are when they're writing the production code. They may end up with a lot of tests that are very fragile, and every little change will impact the test. And obviously now you have a bigger hump on maintaining the code. You need to maintain these two code bases. The other thing to keep in mind is, well, if you like to know if you have the right code, when you execute all of your tests, you should have a high code coverage. And I don't think that we need to pursue or establish a particular target in terms of code coverage. I think it's something that if you're doing test-driven development, you're going to have anyway. You're going to have as a side effect, unless that you're going to be I would say failing at some of the steps in the Red-Green-Refactor cycle. So sometimes we will forget refactoring, and that means that we're going to have some code that is now not being, I would say, supported by the test, and you may execute your test and see that you don't have sufficient coverage because that code hasn't been removed, which is maybe a good discovery, because now you can go ahead and remove that code if you no longer need it. So that's what I mean by effective test-driven development: correctness, robustness, and make sure you have the right quality on the code, both the production and the test code. So the most effective, I would say, test-driven developers that I've seen, they use an outside-in approach. What I mean by that is, if you like to make sure that you are satisfying what is expected, what your user, your product owners are expecting, you need to make sure that anything you're doing in your code is somehow connected with those acceptance tests. So they will start with failing acceptance test, which would be obviously bigger or broader, if you like. And once you take that acceptance test, you're going to go into the other cycle that we just talked about, the Red-Green-Refactor at the unit testing level. So why do we need to have another idea or a similar idea or a different name for a similar idea? Well, the original intent of test-driven development was exactly this. It was exactly saying, well, we have certain things we need to provide. Let's make sure that we have it, that we are growing the code with this test so that we can always say it is correct. But in practice, what we have seen is that developers get so much focus on the unit test and they will miss the other part. And that's why we have things like behavior-driven development, acceptance test-driven development to kind of bring back the original idea to make sure we're satisfied what is expected. So this will help in terms of correctness, not necessarily on robustness, because it depends also on how we specify acceptance tests. If we're always specifying acceptance tests just from the, I would say, positive test cases coming from somebody with no previous knowledge of testing, then we are in the same position. So we need to be careful how we write those acceptance tests. So here's one thing. I feel like developers, we are not great in thinking about what could possibly go wrong. And we do this in our class, in our developer testing class. So we have a self-assessment. So we ask the participant to write a set of test cases. And by that, we mean a specific set of data that will properly test this very simple program. Is a program that reads 3 integer values, and those 3 integer values represents the size of the length of the side of a triangle. And the goal of the program is, by taking those 3 inputs, determine what type of triangle would you form. It will form an equilateral triangle. In other words, all sides will be equal, isosceles triangle, or a scalene triangle. Very simple problem. So we have a standard answer key to this problem, and it's not like these are the perfect set of test cases or all the test cases we need, but it has 14 test cases that definitely you need to have for this program. This will be like the bare minimum of test cases. How well do they do with this? How many of those 14 test cases they typically will identify? Let me show you some results. So this is from the last, I think, 5 years, and so I've done this a number of times. So I have data here for 54 sessions, and that's the total number of learners, 766. So around almost 800 learners who have done this. And out of those 14 expected test cases, the average is 7.1. We're not talking about, kids at school. We're talking about professional software developers. So they're missing about half of the required test cases, the minimum test cases. That means that there is a gap. There is a gap in our testers' mindset. We have seen good cases. We have 10.2 as an average. When we have those groups, we feel like, what we're doing here, are we going to be teaching or talking about something else? But we have seen other cases like really low, 4.5 out of 14. That's an average. So you're going to have in any class, maybe 1 or 2 will have more than 8, and then you have the others have less than 3, and so on and so forth. So what are the typical test cases they will miss? Out of these 14 test cases we have, typically they will miss things like invalid inputs. In other words, all the negative test cases will be an invalid input in this particular problem. Well, sidelines that do not form a triangle. Oh, is that a thing? Yes. So if you have the sum of 2 sides is I would say less or equal than the third, that will not form a triangle. In other words, you will not be able to close a triangle with those things. So typically, they will write a test case like 1, 2, and 3. Those are the inputs, and they will say, oh, that's an scalene triangle. Wrong. 1, 2, and 3 will not form a triangle because you have 2 sides that will be equal to a third. When you add 1 and 2, then that will be an invalid triangle. So that's the first thing they feel a little bit upset about, because they say, well, you didn't say anything. That was not in the specification. Well, guess what? That's the real life. We don't have perfect specifications, and That's why we're talking about testing, because it will help us to ask questions and, I would say, improve those specifications. So depending on your tester's mindset, you may feel like if it's not in the specification, then I need to worry about. Well, you may have correctness, but not robustness. So it's better for us to start questioning, is this a valid triangle? And the other thing that is important is to get to the point to talk about specific examples and specific values. Because sometimes you may say, oh yeah, we'll have a test case with three different sides. That doesn't tell anything until you say what specific values you will try. Would you try 1, 2, 3, or would you try 3, 4, 5? Depending on your example, you may be more or less effective. So that's why nowadays, I guess you have heard things like a specification by example, and that's what behavior-driven development uses, is using examples all the way from the beginning so that you can remove ambiguity before you even start typing the code. The other things they will miss are the combination or permutation. So every time I say, well, invalid triangle when the sum of two sides is equal or less than the third, well, they may assume 1, 2, 3, right? So say the sum of the first two is equal to the third, that's invalid. But there will be some other things they will miss. If that's the only case they have, they will miss the other combinations, like when happens that is the first that is the largest, and then the other two will be the sum that will be equal to that one. They will miss that. Say, well, is that needed? Yes, it's needed, because if you have only 1, 2, and 3 and say invalid, but then I try 3, 2, 1, you will say it's an Scalene triangle. That is wrong. So it's a very simple problem, but I think is reveal a lot of things that we need to work on. So what a typical tester will do, what are the I'll say the tools and techniques they have that they can use for, let's say, identify good test cases. So they do things like domain analysis. Domain analysis is the idea of looking at the domain of a particular function. If you treat your software under test as a function, something that will take some inputs and transform that into an output, then you have input domain, right? So what are the typical things that we can pass as an input? It will help you to identify invalid test cases. So you start basically partitioning that domain or having equivalence classes, and then those equivalent classes will have boundaries around it, and you need to test those boundaries. And you do the same thing for the output domain. So in this particular problem, they typically get right those test cases like, do you have a valid test case for detecting an, let's say, an Scalene triangle or equilateral triangle or an isosceles triangle? So that's what the specification says. We have 3 possibilities, and they will have test cases to satisfy each one of them. And then you feel, oh, that's fine. But we're going to miss some of the other stuff that we need to take care of on the inputs. The other technique that is actually very valuable to validate, and this is not necessarily a testing technique, but it's a good technique for us to analyze what kind of test cases we need, is decision tables. A very simple thing. We have seen this for requirements analysis, and that's what we're doing here. So since we're testing first, what we're doing is it's not actually testing, it's more about refining our requirements by using this test. So a decision table will be very useful in this situation because, well, there's a combination. There's a combination of what if is the first 2 sides are equals or the first and third. So we want to make sure we cover all that. If we use the decision table, then we feel more confident that we have sufficient functional coverage. Similar to decision tables are state transitions, when we have states that will be effective for some event, and then you have to transition to a different state. If you like to have sufficient coverage of those state transitions, then you want to make sure you kind of have a table that you make sure you have, you can simulate all those scenarios. And then you have cases in which you have a large number of variables taken a large with a large domain, and you will not be able to test everything. So you need to make a decision here, how much will be enough. So there is this idea of all pairs, which is make sure you're testing every a pair, not all the possible combination. A little bit kind of over the board here for this, the intent of this talk. But let's get into some of the I would say thought process if we would like to apply these techniques. So we have a software under test. I'm using the term SUT here. And we're going to be looking at behavior. If we're starting from the outside, we need to be able to express, given this input, I should be able to see this output. And the case that we have in mind here is that we're going to need to take some inputs and classify that inputs, and based on that classification, we're going to determine what is the output or provide a particular behavior. So this is a good case for us to use domain testing. So domain testing is concerned about finding defects in the way that the software under test will handle the inputs. How are you going to classify those inputs? So in this case, we have 3 integers. You need to be able to classify those inputs depending on what kind of triangle you're going to form. And what can we use to make sure we do a good analysis of valid and invalid test cases? You can say, well, I don't need to use any other technique than just think about it. But, sometimes they will have, you have some problems that are a little bit difficult, and you would like to make sure that everybody is on the same page about what it is before we dive into code. So one technique that I recommend, especially for developers, since we're going to be designing the code guided by the test, is design by contract. So design by contract is a design paradigm. It's not a testing paradigm. And the idea is that we're going to be modeling the interaction between our software units as a real-life contract. If you think about any contract, there are certain preconditions that you need to satisfy in order to enter to that contract. For example, you may have a rental agreement. For that rental agreement, you need to have let's say, a given credit score. You need to have maybe a given income, something like that. If you satisfy those preconditions, then you should be able to be considered for that rental agreement. That means that on the other side, we need to get the past conditions. In other words, the possibility is to get accepted. So if we think in terms of the triangle problem that we're talking about here, so that triangle has some inputs, and those inputs are integers. What will be the preconditions for those 3 integers? It will be the past conditions. This is very straightforward. We may say that preconditions are just the things that we expect to be satisfied. So I will expect that my inputs will be positive integers. Well, that's what I expect, but I have no control. Somebody introducing negative numbers. So I can assign a name to this precondition. I may say positive side lengths, and I have specifically how can I validate that. Also, I may require that this side lengths will form a triangle. And here's the rule here. I'm applying that knowledge from my geometry class. What are the things that will form a triangle? Make sure that the sum of any 2 sides will be greater than the third. And then I have the past condition. If I satisfy those preconditions, then I should be able to get this result. I should be able to see that we're going to get one of these possible outputs. It's going to be either equilateral, isosceles, or S-clean. Sounds great. How can we use this for testing? Well, what we have done already here with this contract is that we are able to identify, well, what are the valid versus invalid inputs. And also we are identifying some, I would say, exceptional cases. Those are the things we tend to miss. So in this case, we will not miss it. If you're going to be test driving this code and you have this knowledge, for sure, you're going to be preventing a lot of defects. Now, one thing that you may feel is that, well, what if I don't want to require that much for this function? I would like to be able to say, you can pass whatever you want. It's going to be an integer. If you pass a negative integer or they don't form a triangle, I will handle it. In other words, you want to make sure your software is now robust. It will handle those things properly. So you may say, well, removing those preconditions we may need to introduce a past condition. And the past condition is now we're going to have a possible output that will be an invalid triangle. So now our output domain has 4 possibilities, and our input domain is kind of wide open. It's, as long as it's 3 integers, will be fine. All right, so we can write some tests for this. But the other thing we may want to consider is, given that we're going to have a bunch of combinations and you want to make sure you have everything covered, is to use decision tables. So on decision table, we have is conditions, and then we have actions. For this particular case, it's very simple. You have the 3 cases for invalid triangle, and you have the other cases depending on if the sides are equal or not. There are some invalid cases because you cannot have something like A equals B, A equals C, and then B is not equal to C. That would be logically impossible. So we remove all of that, and this is telling you that you may have A test cases right there. So these are A test cases, and now you need to come up with the specific examples. So with this knowledge, I think many of those test cases that are missing, all those negative test cases, they will be able to answer this correctly. And if they need to implement this using test-driven development, they can use these techniques either upfront. I would recommend to start with the contract, write some of the tests, drive the code, and then at some point have a discussion about we have everything covered, is anything that we're missing, and use the decision table for that to kind of validate your test. But also you can use code coverage to see if we have a sufficient coverage. In this case, this is partially implemented. So essentially using this test on the left, and I can see how much of my code is being exercised, how much coverage I have. As you can see, there are some things here in yellow, and that means that we have essentially some scenarios that we are missing. All right, so I think this is good for now. I would like to switch and do a little bit of coding in my development environment. So going to be doing some coding here, and for this I'm going to be using Eclipse. In my implementation language will be Java and JUnit. So I have the simple problem of the triangle type. I have the description here. One thing that we want to remember about TDD is that these 3 laws of TDD: do not write any production code unless it's to pass a failing unit test. Do not write more than a unit test that is sufficient to fail, and write just enough code to pass the one failing unit test. So I'm going to try to follow these laws strictly so that we can experience the test-driven development approach. So test-driven development, the first thing I will do is to write a JUnit test case. Since we want to start with a failing test, I will be collecting my tests in a test case class. So I'm going to have something like triangle type test. So I have this, and this automatically create a test for me that I can say, well, this is, I have the first step on a test-driven development process. I have a failing test, but obviously this is a silly test. This is not what I want. Let me close some of these windows here so that we can have more space. So I'm going to start writing some tests based on the knowledge that we already have from the design by contract analysis and from our domain analysis. We may need to start writing some tests. I like to start with the exceptional cases first, because those are the ones that we tend to miss and forget. So I don't want to forget all those invalid test cases. So I will start with an invalid test case. I will name my test something like classify as invalid when the sum of two sides are equal to the third. Very long name, but it's good. I like it because when I see the test, I will be able to see what is going on, see what is the intent of the test. Now, for any test, we need to have a setup, an exercise, and verify. So it's like saying given, when, then. But for this case, it's going to be very simple. So I think we can have just one single line to validate what we want. So I can have something like assert equals, what do we want? Now I need to think about what is the code I wish I have. So I'm thinking that I'm going to have sort of a enum, a class that we're going to call triangle type, and it will have all the possibilities. It will return what type of triangle it is, and we're going to have a function that will classify the inputs that are going to pass as parameters. So let's say that we're going to have something like triangle type that I'll start with the invalid. So I'm assuming we're going to have something like invalid, and then will be my exercise. I will call something like triangle type classify, and this is method I don't have. It's a method that I wish I have, and I call it classified, and then I will have 3 integers. And I will start with this silly case, right? 1, 2, 3. So now this is a test that I cannot even run, so this is a failing test. So build failures are failures, so I need to first get rid of this build failure by creating this class. I will create a triangle type class. Instead of putting it into this folder, I would put it in a different folder, source folder. All right, so now I have a triangle type class, and I have a triangle type test class. So I like to put it side to side so that I can see the code growing, or see how my test will be driving the other production code. So now I have this is a build failure, and the same, well, seems like we could have an easy solution is to create a constant invalid, or create a field invalid, but that's not what I have in mind. So given that this is a design technique, I can start kind of enforcing what I want from a design standpoint. So I can essentially say, no, I don't want to have that. And if I want this to help me better, I will say that this will be in num. So now when I go back here and I say, well, what are the options for me to get rid of this build failure? Now it's offering me something that I can definitely take advantage of, and essentially something that I don't need to do anything. So the IDE is doing it for me. Now the next build failure that I have, so still I'm not able to run this test because I still have build failure. I need to create this method classified, which is the whole point of this exercise. So I'm going to create this, and this is already saying, well, this is going to be static and it's returning an object, but this is not what I want. I want this to return a triangle type, right? This is all I need to get rid of the build failure. I know that that test is going to fail, but that's what I want. I don't want to trust any test that I never seen failing. I like to see it failing first to make sure that this test is somehow doing something. So I will execute it, and then I will see, well, you were expecting invalid, but this is returning null, right? So now I need to do the bare minimum to satisfy this test. I could easily do something like, well, I can return invalid. I will do it. You have a green bar. But we know that this is not what we want at the end. So sometimes you don't want to be that silly. You want to make sure that you have the actual code. So given that I have a green bar here, I can do some refactoring and say, actually what I want is this to have an if statement here that will say if I plus j is equals to k, then return invalid. Now I need to have a return here. I would say if it's not that the case, I will return null. This is the only thing that I'm handling in this one. So this still should pass the test, right? So I passed my test. That's great for now. But one thing is, this is only checking one possibility. It's only checking if 1 plus 2 is equal to 3, but it's not checking the other two possibilities depending on the order of the parameters. So I can go ahead and say I need to implement those different scenarios, so I can just basically duplicate this line here and just go ahead and say, well, how about exchanging this to, right? And then I execute, this will fail, right? So I need to go ahead and implement this other part, or if I plus k is equals to a, right? Oh, it's not working. Well, because I did it wrong. So it's my test that is wrong. It is if j plus k equals I. All right. That's what we're looking for. This is running really slow. Now, you get the point. And now we have another test case in which is going to be put in, let's say, this guy here in the middle. And then you're going to have the other test case. If I plus k is equals to a. Right, so we have this. We can do some refactoring. First of all, I don't like the I, J, K. Mathematician you should like better. Things like A, B, and C. So I will refactor this. I will rename this variable. So it's one of the things you want to remember. So I would like to call this A, right? And so we'll pass my test, no problem. And then I go ahead and replace this other guy here, call it B. And then finally, the other guy here, we'll replace it with C. And there you go. I like that better. But the other thing I can do in terms of refactoring is, well, this kind of a little bit confusing or too long. I would like to maybe extract this into a method, have clean code. So I will basically extract this into a method, and I would call it sides do not form a triangle. Okay. There you go. So looks cleaner here. I have this here in the bottom. So I can go ahead and keep adding the other test. So there will be similar tests now for that when it is. Let me just go, and for the sake of time, I'm going to be duplicating some of this thing here. So invalid when the sum of two sides is bigger than third. It's a different scenario. So what I'm going to do is to replace this with a 4 here, another 4 here, another 4 here. Run. It's less than. Okay. So those tests will fail. You're expecting invalid, you're going to fail. So I'm going to need to just go into this function and say, well, if it's less or equal than, and that should do it. right? So I have those test cases, invalid test cases, and then I just need to go and move on to the next case. The next case could be, well, I would like to validate, let's say, isosceles triangle. So classify as isosceles when two sides are equals. And then it's going to be very similar, and we're going to be continually implementing. So the whole point here is that I can go over, and this is a very simple scenario, but I think from a practice standpoint, it's very good because you can see the combination of these two different testing techniques to drive your code. I can keep going and finish the whole thing, but I will show you a kind of the solution to this. It could be kind of the final solution if we keep going. So I have this test, all the tests, two sides are equals, when all sides are equal, when they're different, and then I have my source code here. You can see kind of sort of clean code. I may want to maybe extract this just for, I would say, symmetry, to have another private method that will determine if two sides are equal, all the sides are equal. Pardon me. So essentially, this is the way to go on preventing defects by doing this. Now, the other thing you may want to see here is that if you see, all the tests are very similar. So it's like I'm always a certain equals something, and the only thing that is changing here is the values that I'm passing. So in other words, the body of each one of my test method is the same. So I don't like duplication. That's one of the things we like to do in refactoring. So this is one scenario in which you want to use parameterized tests. So parameterized tests means that you can have with the help of your testing framework, obviously, you can have these same test cases in this few lines of code. As you can see, we have, this is what we're going to be testing, and these are my test cases. Essentially, this method, what it's doing is returning these arguments. It will be returning this input 1, 4, and 2, and this is what is expected. So what the test runner is doing here is to instantiate, passing these parameters here and checking here in this assertion if this is being met. That means that if I would like to add another test case, I don't need to write another test method. I just need to come here and add another line, another return value, and that should do it. And you can see this running. So we're going to see that the output is slightly different. So you're going to see here, if you don't have any documentation, then you feel like, how do you know which one is failing? One of them is failing. How will we know? Well, you have this as well, that you can instrument how you're going to name the test. So this is the first parameter, second, third, and fourth. So it's like saying these three input will form this type of triangle. So you see the output. So it's very well documented. So now we can say this is executable specification. So this is a very simple scenario. I just wanted to show you something and to go through the thought process of automating tests, but using effective testing techniques first. We can try a different, I would say, problem that would be a little bit more challenging, but for the sake of time, I will basically leave it here. So I'll come back and have some final thoughts here about this idea of effective test-driven development. And then we're going to have some time for questions. So key point here is, at the end of the day, developer testing, no matter what you do, if you're doing testing after, testing before. The whole point is to minimize the gap between when a defect is inserted in the code and when that defect is found and removed, obviously. So the whole point of test-driven development is that because you're testing in really small batches, you will have frequent feedback. You will be able to find what the problem is. It will be easier to find what the problem is. And, if you cannot fix a problem in a matter of minutes, that means you can always roll back to the previous stage in which you have all the tests passing. The other thing to keep in mind is testing is usually as a way for us to find defects. That's the traditional definition of testing. Finding defects, that's great, but it's better if we can prevent them. So this will be even more effective if we can prevent defects before, and that's essentially what the whole process of using acceptance test-driven development will help you to do by asking those questions early on, removing ambiguity. The other thing to keep in mind is to embrace the tester's mindset. In other words, you need to think aggressively about how you're going to test your code, what are the things that could possibly run, not just all the positive test cases. And for that, you need to be aware of all of these testing techniques that you can use to think about different scenarios. So we talked about a few of them. Some of them are not entirely testing, like design by contract is something we can use to guide a process to identify equivalence classes, boundary test cases, and then you have also the decision table when you're dealing with combinations. So make sure you're using all of them. When you write a test code, make sure that you're paying attention to the quality of the code. Make sure that you're keeping that code as clean as possible so that any change in the production code not necessarily means that we need to go and change our test code. It has to be maintainable. If it's not maintainable, then we're going to lose a lot of time just maintaining the test. And at some point you feel like, well, I don't want to keep investing time on this, and then you're going to lose, the benefit of having automated test. Finally, make sure you never touch a code that have no test. In other words, if you need to deal with legacy code that have no test, before you touch any code in there, make sure you write automated tests. Make sure you measure coverage to see that the area that you're going to be touching is actually being covered by that test. And then you can go ahead and implement your changes. This is very high risk to deal with legacy code, changing it, not because it's difficult, but also because it is legacy, but for some reason it's still there. So in other words, it's still providing benefits to the organization. So you don't want to break it. And when you don't have tests, you don't have something that effectively will tell you when you are breaking it. And finally, the other thing is keep in mind that quality is more than testing. Testing usually will explore things that we can observe, but there are some other design attributes that you also need to pursue, like make sure you have minimal complexity. Testability is one of them. So test-driven development is one that you can get, but there will be some other things like maintainability, flexibility, and for that you need to make sure you understand some good principles of clean code that you can apply when you're doing refactoring. So additional resources, if you like to read a little bit more about this, so I recommend these 3 books. The first one by Freeman and Price is a very good book. As I would say, it's my go-to book on test-driven development, even though it's not written by Ken Beck. It has a very good discussion on the outside-in approach that I talked about here. And then you have continuous delivery that will go beyond testing, talking about all the things that you want to check, and like continuous inspection before you even commit the code and after you commit the code. And finally, I have the third book is XUnit test patterns, and this one will give you a catalog of different patterns that you can use when you're automating tests. It will have a long discussion about test doubles, mocks, stops, all those kind of things, and other things you may want to use depending on the problem you have for automated tests. So that's all we have. So I think we have time for a few questions. So appreciate your time, and let's see what we have. What are the questions? And I'm going to go from there. So you're going to be waiting for some of your questions. All right, so I have a question here is, if we assume that developers are typically not well prepared to create an adequate set of test cases, then does TDD assume require that the development team hires one or more testing experts? Are you implying that test cases be created collaboratively? That's a funny word. Yes. So the thing here is, and this is something that is now the norm. So the norm is that we have cross-functional teams that will have people with testing background, other members, with strong development background. So more and more we are basically working together. So you may have a team member who is a tester that can help identifying good test case scenario from the outside in approach. They can actually go ahead and implement some of those high level scenarios, not the actual code, but it could be just high level scenarios. And then the developers will come in and kind of connect those scenarios with the actual code. So you can definitely approach this differently. I would say, first of all, we want to make sure that everybody's trained on these essential techniques. You don't have to be a tester. You just need to grow your capability as a tester, developer tester. And then you still need to have tester for other type of tests. For example, exploratory testing. This is not replacing exploratory testing. You still need to have somebody who is going to be taking a more discovery approach, trying different things that we couldn't anticipate. So that will be my recommendation. There have been different approaches that we have seen in the past. We have seen the idea of test dev. So these are developers. They're driving all the automation, especially if you have no history automating tests. They usually will start a process, but eventually we want to have the developers to be able to automate their own tests. So they need to have a way to say, is doing what is expected. I don't want to have anybody else, I don't need to have somebody else telling me that is doing what is expected. All right. So another question here is, how strictly should we follow this first law of TDD? Should we compromise a bit if we have a deeper understanding of the requirements? So the first law of TDD is, do not write any production code unless you have a failing test. So you need to have a failing test first. So the question is, should we always follow this rule? Should we compromise it a bit if we have a deeper understanding of the requirements? If we have a deeper understanding of the requirements, why not express our requirements as a test? So we may feel like we have a deeper understanding of the requirement, but keep in mind that sometimes you have a good understanding of the requirement, but by the time you're going to be typing the code, you're going to be making a mistake. Instead of typing greater than, you're going to say greater or equal. And since you don't have the test, then after you have the code, you feel like, do I need the test? So you don't have that motivation to actually go ahead and then write a test. Now, one thing to keep in mind is sometimes you may want to make sure that you're not just jumping into writing a failing test. If you have some understanding of what is going on, you may do a little bit of design up front, what kind of solution you're trying to implement. And you just need to make sure before I implement anything on my code, I need to make sure that this is supported by a test, and which is the same as saying this is being supported by a requirement. Another question here, if we assume that developers are typical, oh, I already answered that question. All right. So, all right, so this is all the questions I have. Keep in mind that these materials will be available for those who like to get a free trial on demand. So if you guys have no more questions, I really appreciate your time, your dedication, and your attention on this talk. And I wish you the best. I hope that you try some of these things. If you like to get in contact with me, I can share my contact info. Eventually, you have questions or um, comments about this, you can use my email, and also on Twitter you can send me a message there, and I'll be more than glad to exchange some ideas with you. Thank you very much, and I hope you keep enjoying the conference. There's still a lot of more content coming, so keep enjoying the conference, and see you later.